Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, continuous sub-array sum. So let us first read this question, and after that we will be checking about the constraints and then about the examples and in which company it was asked, and then finally the coding of this and the time complexity and space complexity for the same. So we are given an integer array nums and an integer k return true if nums has continuous subarray of size at least 2 whose elements sum up to multiple of k or false otherwise. An integer x is a multiple of k if there exists an integer n such that x equals to n into k and 0 is always multiple of k. So from this question statement, we basically require minimum 2 element subarray and maximum could be anything. And the condition for that minimum 2 subarray is that that particular means when we sum up those two elements, then sum should be multiple of k. So that's the thing which we are required to do here. And now let us take about the constraint. So constraint here is that num's length is up to 10 to the power 5, and then each element can go up to 10 to the power 9, and the sum of nums of I can go at max up to 2 raised to power 31, and key value can also be go up to 2 raised to power 31. And here the minimum value is 1 of the k, and k can't be 0 or less than 0. So that's the thing here. Now let us start that how we can do this particular question. Before that, let me tell you that this particular question was being asked in Adobe, Microsoft, Amazon, and Apple. So that means this is like another interesting question. So let us go ahead with the same. Let me first show you some explanation for the same. So basically, as per the question, we require subarray with minimum 2 elements, right? That is just minimum. At maximum, it could be anything. So let us from that about the mathematical part because we require modulo and so on. So suppose A and B are two numbers and D equals 2, difference of these two numbers. So the thing there, it was given that sum of these two numbers should be multiple, right? So here we are checking with the difference part that if we do modulo with that, so it should be equal to 0, right? That is, it should be, that difference should be multiple of the same. And then replacing the same with k and then using that distributive or you can associative, not associative, but distributive property, then this is the thing which we are going to do, and then both of them become equal, right? And thus, in this particular scenario only, we need to figure out that if A modulo K is present in the hash table, then for that fact only, for this B modulo K, because both of them are equal, right? So either of them should be present already in the hash table, and then after that we can check that if it is present, then surely it should be equated to this, and thus we are able to figure out with a particular subarray whose length is uh, greater than 1. So from this we can see that how mathematically we can prove about this particular question about how we can get into the same. Now let us go ahead. The thing of that two minimum elements, how we can figure out for the same. So the thing is that current index minus the previous index, if that is the thing, right, and it should be greater than 1. So in that particular scenario, that hash map signature should be something like this, that running some comma index, right? And that will be contributing towards that. Yeah, now we are able to figure out with a particular element, this should be having the in means particular subarrays where two elements are being present, and after subtracting them, we are able to figure out the element count as greater than 1. So that's the thing here. But I know that it would have been typically because without any example, I'm explaining this. So it was just a sort of overview thing that what exactly mathematical reasons are behind the same. So let me explain you with some example as well so that it would become somehow much more easy. that what exactly I was saying and so on. 1 minute. So here, if we take this first example, what I was saying about that subtraction and modulo with that k, right? So I was basically letting you know that if we do subtraction part, right, then how it could be, then after having that distributive property application, then it simply refers to that how we can equate these elements. So in that context, it was about the subtraction part. In this question, we are asked with the addition, right? So here, if we do 2 modulo, what we see that 6 and 4 modulo 6, right? Then for both of them, we are getting 4. But when we add both of them, 2 plus 4, then it would be 6, right? And then doing modulo for the same, we will be getting 0, right? And that 0 is something which is being required. Actually, from this example, this is some other sort of example. That other explanation part is not corresponding to this, but this example is for other test case that here we are getting this 0. So corresponding to this 0 only, we are required to store in our hash map earlier only the running sum which is 0, and corresponding to that we are storing the index. So that's the thing. So -1 if we are storing there. So this would be some previous index, right? And here after getting this sum, so this is at in the 0, 1, 2, right? So when we do current index minus previous index, so then it will be equal to 3, right? Which is greater than 0. So because of that fact only, we will be easily able to figure out that yes, this particular exists. So that's why I'm saying this is some other test case. Corresponding to that explanation, now if we check for this 23, right? Then do modulo with this 6. Yeah. So modulo with 6, that would be something 18 after 24 is there, right? So yeah, here we will be getting 5, right? And then here we will be just storing this as the running sum, and then index is basically 0. Then for this 2 modulo 6, we will be storing 2 in this, and then for this 6, we will be basically not individually but by adding up the previous one also. So it will be stored at 23 plus 2. So that 23 plus 2 would be 3, 4, 5. 25 modulo 6, that will be 1. So like that manner, and then corresponding to this 6, it will be 6 plus 5, that is 11, and 31. 31 modulo 6, so that would be close to 5, right? Should be 5. No, 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 not 5. It should be 1 and 2. So now here we figure out that this 1 and 1, both of them are present in our hash map, right? So here only we can directly check that this 2 minus 1, right? So here it is not greater than 0, right? So that's why we will be moving ahead for the same. So here we check for 4 plus 1, that will be 35. So here 5 and this 3. So now here 5 and 5 was already present. Now we will be checking 3 minus 0. So yeah, it is greater than 0, right? So at that moment we will be getting our answer and we will be returning true. So the thing here is that at every point we will be um, accumulating the sum till that particular point and doing the modulo with this particular k, right? And then storing that running sum corresponding to that index in our hash map, so that we are able to figure out that at each point are we able to figure out with the particular with a particular two elements which can be our answer. So that's how we will be going ahead with the same. So let me show you the coding part for the same. So now here it's coming. Okay. The first thing we are checking that if our nums dot size is less than 2 or not. If it is less than 2, then we won't be able to figure out with at least two elements, right? So that's why at that moment we will be returning false. Now we are having this hash set where we will be storing the running sum and the respective index which would be there. That we will be storing here. And the starting, we will be storing a 0 index and -1 corresponding to that. Here, why we are storing the same? This 0 is basically the running sum, right? And this running sum is corresponded to this -1 index. So this -1 index will also be letting us to store for that part. If our first one, which is there, if say it was 6, then 6 modulo 6 would be 0, right? So, and if it is 0, then it should be present in our this hash set. So that's why when we do this, what do we say this? 0 and then its corresponding index was 0, right? So when we do the 0 minus 1, right? So we will be getting 1 as the index, right? So that 1 is as the count here, right? So that's why for this particular thing, we are required with this. So that's why we are doing this. And then running some starting from 0, then at each moment we are adding up to our running sum. And then if our k is not equal to 0, for time being our k in this particular question is not even equal to 0 or -1, but still we are just keeping it from our side. If such test case was there, then our running sum, we are doing this means at every point we are making a running sum such that it becomes more, it becomes the remainder. Basically, when we divide that particular running sum with the k, so we are just storing the remainder part of that running sum, and then we are trying to check that if we are able to find that running sum or not. If that particular is basically means that present index which is there and the previous index which was there. If after subtraction we get greater than 1, then it's okay. We will be returning true at that point only. And if we are not able to get, then we are not returning false here because there could be possible answer in upcoming. So that's why. So else portion is that if we are not able to figure out with this particular means that was not present, then we are required to store there. So that's why we are storing that remainder portion with its corresponding index, and at the end we are required to return false. And this false would be returned when this particular for loop is completed. So then at the end we will be returning false if it would not return this true at any moment of time. So this was all for this particular question. Now comes the part for time complexity and space complexity. So basically, here we are using this unordered map. This unordered map which makes the space complexity order of n. And now any other thing, I don't think so. And because of this order of n is the space complexity, oh sorry, time complexity. And this hashing is already order of 1, so it doesn't add to our time complexity. So that's why overall time complexity is order of n, and the space complexity here is also order of n. So basically this is a solution of order of n time complexity as well as space complexity. So yeah, this was all for this particular question. If you have any doubt, you could comment that down. And if you like the explanation, then please do like and subscribe to my channel. So yeah, this was all. Thank you.